Assalamualaikum everyone. So, for microprocessor mini project, we from Fancy Group want to present to you about smartphone. Before we started, we would like to introduce ourselves.
My name is Muhammad Iqbal bin Ma'akhir.
My name is Muhammad Syahiran bin Ambandi.
And my name is Muhammad Faiz bin Muhammad Fauzi.
This is product illustration for this product. Introduction. What is smartphone? Smartphone is known as temperature-based fan speed control. Temperature-based fan speed control is a system that used to control the cooling system automatically based on the room temperature. The system uses temperature sensor to detect the temperature of the room. The system uses an Arduino board to implement a control system. Then the Arduino board executes the contrast of current temperature and set temperature based on the inbuilt program of the Arduino. The generated pass from the board which is further fed to the driver circuit to get the preferred output to the fan motor. The outcome obtained from the operation is given through the output port of an Arduino board to the LCD display of related data. Hence, the speed of the fan is determined by room temperature. As example, the speed of the fan will accelerate when at the peak noon, but at the night, the speed of the fan will decelerate because the temperature at the noon is higher than the temperature at the night. Problem statement. Why use smartphone? Sometimes the use of electric fans is a waste of energy due to human attitude. People or users also mostly demand something that can be easily used without wasting their energy and time. Most people feel the inconvenience about changing the fan speed level manually when the room temperature changes. In order to overcome the problems, this project developed an automatic fan system that automatically changes the speed level according to temperature changes. Then the system will reduce or minimize the use of electricity, and it also will conserve human energy. So, it is recommended to use smart fan to solving this problem.
Objective. The objective for this mini project is to study and apply the Arduino code and components in Thinkercad software for the specific product application. Second, to develop an automatic fan system that can change the speed level due to the environment temperature changes. Third, to achieve the comfortable surrounding air based on the environmental temperature and time. Next, to reduce and save the electricity consumption in daily use. Lastly, to save the time and energy for adjusting the fan speed based on their surrounding temperature. Electronic component detail and cost. First is Arduino board. We use Arduino Uno R3 type for our mini project. Second is temperature sensor. We use it as the main component in our mini project. Basically, it used to detect the surrounding temperature. Third is the LCD display. It is used to show the surrounding temperature and the speed of the fan. Next is resistor. We use two resistor in our circuit of this mini project. Then transistor, diode, capacitor, LED, and power supply. We use a 9-volt battery or adapter as power supply in our smart fan mini project. Connecting wires. We use the connecting or jumper wire to connect our components in the circuit. And of course, we use fan as our product is smart fan based temperature. And we use 9-volt DC fan. Lastly is breadboard. We use it to connect all those components on it. Circuit diagram. So this is circuit diagram for our smart fan mini project.
As the system running, the LCD will display the temperature and percentage of fan speed. At the current virtual time, 12 noon, we can see that the motor rotates at average 300 rpm. LCD is displaying the current temperature 34 Celsius and the current percentage of fan speed 73%. As we fast forward the time, we can see that the temperature is decreasing. So, at the current time, the LCD is displaying the current temperature 24 Celsius and current percentage of fan speed 30%. The motor is rotating at average 90 rpm. The LCD then will continue to display the temperature and percentage of fan speed in real time. As we fast forward the time again, we can see that the temperature is increasing. So, for the current time, the temperature is 33 Celsius, so the fan speed will increase to 69%. So, the main objective of the system that to change the fan speed based on temperature is achieved. First, take Arduino, breadboard, and LCD display. Connect 5-volt power supply, ground, and input voltage to the breadboard. Connect LCD to the ground and voltage current collector to the power supply. Then, connect each data bit to the selected pin. Take battery and connect the ground and power supply to breadboard. We use DC motor to simulate the fan motor. Connect to the diode and input voltage. NPN transistor is used to amplify the weak signal enter into base and produce strong amplified signals at collector end. The collector is connected to the positive input voltage. Connect the DC motor connection to pin 11. Take the 10 mF capacitor and connect to the DC motor connection and ground. Connect emitter to the ground. Take the most important component, temperature sensor, and connect to the analog pin, ground, and power supply. Take LED and 1 kΩ resistance and connect to the pin 8 and ground. Include liquid crystal from library to allow Arduino board to control liquid crystal display or LCD. Define the numeric variable by integers. Use pin mode function to configure the pin into output or input. Make a loop function to make the function runs over and over again. Set the range of temperature for the fan speed range. Use LCD print and its data and base to display the temperature and fan speed percentage. Firstly, we make a fan guard. Fan guard is used to provide a physical barrier around spinning fan blades to prevent accident contact with fingers or other objects. Next, we make a motor housing. Motor housing is to provide protections to the moving parts inside the motor. Next, we make a front cap. Next, we make the blade for the smart fan. Smart fan use 4 blades as it will be less noisy, so it will decrease the noise pollution. Now we finish the upper section parts of the smart fans. Next, we continue the lower section of the fans. We make the stand base and stand. The height of the stand is adjusted for the table fan criteria. Next, we make the on-off buttons. And lastly, we make the most iconic parts of the smart fans, LCD display. The LCD display will display the current temperature and fan speed percentage in real time. And finally, this is the full 3D modeling for the smart fan produced by Fancy.